Hello and welcome to today's IBM Developer Talk. What is serverless? We're really glad you're joining us. I'm your host today. My name is Miriam Oaklesby and I'm running our developer event platforms in Germany, Austria and Switzerland. And I'll start today's session with a little bit of housekeeping. Hi, Nathan. So Crowdcast is quite a new platform for us. Hi, Fliss. But just so you know, we'll be communicating with you in the chat. That will be my job. I'll be keeping an eye on it during today's talk. And for any questions relating to the workshop, you can use the separate Ask a Question function, and we'll be answering those after the talk today. Hello from Innsbruck. Hello, everyone. So like many of us this year, I'm in my home office. I'm joining you from Berlin, Germany, and we usually have very interactive sessions. So let us know where you're joining us from. Tell us today in the chat. And while you're doing that, if this is your first meetup with us, I've just got a little introduction. So I'll just share my screen. Here. This is our main IBM developer meetup group, meetup.com/IBM developers. And this is where we list all our different events and activities. So take a look at that. You can make sure you won't miss on any of our future events. And we've got very exciting sessions coming up. Don't miss the Code Engine session on November the 5th and the free Digital Developer Conference. We've also got some very exciting data science and Quarkus sessions coming up. So that's where you'll find out all that information. We've also posted a link today to a free IBM Cloud account, and I'll post that link in the chat as well. And so don't forget to get your free IBM Cloud account. But enough from me, it's not about me today. Sugandha, we are so excited to have you as a guest speaker. Sue is a software developer for IBM Research and Development in Boeblingen, Germany. And we're really excited to have you today. The stage is yours.
Thank you, Miriam. Hello, everyone. My name is Sugandha Agrawal. I'm a software engineer. As Miriam mentioned, I work for IBM Research and Development Lab in Boeblingen, Stuttgart. I see there are a couple of people from Stuttgart as well. So yeah, I'm going to talk about serverless today because I've been working with serverless for past 3 years now as a backend developer. And this is also something that I'm passionate about. I really like to talk about this, talk about the product that IBM has, which would allow you to explore the world of serverless. So here I am. And now I would like to start sharing my screen. So I'm going to turn off my camera. Hope you remember my face by the end of the talk. And now I'm going to start sharing my screen. Only if I can find that. Miriam, could you give me a go if you see my presentation now?
Yes, it's looking all good.
Perfect. So you can find me on my Twitter handle, Sue from India. I like to talk about technology generally on Twitter and anything exciting that you would like to know about. And as said, today's talk is about what is serverless. I'm going to give you a brief about what serverless is, why you should care about serverless in general, what serverless versus function as a service is. IBM has an offering called IBM Cloud Functions, which is a functions as a service based on serverless architecture. And a bit about that in an introduction as well, what all we offer and how you can leverage that. We're going to do one very cute and a small demo just to give you an idea of how fast you can get your functions to work. And in the end, I would like to touch base on what are the real use cases, what are our current customers using it for, and you get to know about what are the different fields where you can use serverless models. So starting first, if you see this chart, you see that when we're going from left to the right, from on-prem to the FaaS model, these are the different as-service models that are available in cloud computing world. And the major difference between these is that we're trying to increase abstraction from the users. So if you have certain thing that is on-prem, you are the ones who are responsible from the bottom to the top layer. You need to get to take care of your hardware, virtualization, what are the operating systems running on it, security patches, name it. You have to take care of everything. You have much more flexibility, but the user has to take care of everything that's coming. Then is the next model, which is infrastructure as a service. As the name suggests, the infrastructure is provided by a vendor. So you can pick any of the cloud vendors which are available who are offering the service, and they would take care of the hardware and virtualization for you. So you basically need to tell them about what the requirements you're going to have for your particular application to run, how the hardware should look like, what CPU, what memory, and everything else on top, starting from operating system until your application layer, is something that you manage. So this kind of gives you a flexibility to take care on only a particular part of the process, but everything else has been managed by platform. Well, this was not enough when you're talking to developers who really just want to run their applications. And then came platform as a service. So the runtime operating system virtualization and hardware, this is something that the vendor is going to take care about. And all you need to take care about is how you need to run your applications and if you have functions on top. And I'm going to talk later about what exactly functions are. And then comes functions as a service, which has much more abstraction from you. So you do not need to care about what kind of runtime you need, what is your server going to look like. All you do is write small functions, which are nothing but business logic. And these are very small parts. So it's even molecular than in a microservice, and we'll touch that later. So as you see, when you go from left to the right, you're trying to increase the abstraction. Obviously, you're also losing the flexibility and freedom, but in many cases, that's the use case. For example, I, as a developer, if I want to try something, I do not want to take care on managing all the infrastructure underneath. I just want to run my application. So the compute model that we see here are like, we have physical machines, we have virtual machines, we have containers, applications, and functions. If you want to have more of a control on the things that you're working on, then physical machines, virtual machines are something that are probably perfect for use case. And when you're all into caring about what the speed, like you want to be very productive and you want to be very speedy with your releases, or you want to have the ease of use, you do not want to understand more about virtual machines or containers, then you would go for applications and functions. And the middle layer is pretty clear. You're trying to gain an operator experience when you're trying to have more control. So the admin guys or the DevOps guys are the more who have more operator experience. Like when you're trying to manage a Kubernetes cluster, you need to be pretty careful about what Kubernetes does. So it's a very powerful tool, but it's pretty vast. So you need to know about the do's and don'ts. Similar thing is when you just want to have a developer experience, then the obvious choice in this case would be applications and functions. So it's the same thing, right? Like you have this car and you want to go from point A to B. So the choice is yours. Either you decide that you want to build a whole car by yourself. So you decide that you're going to have the machine by yourself and you're going to put every hardware on top and you're going to take care of the operating system, all the security and admin patches that need to be there, everything. So you do not want any dependencies. All you have are the spare parts. Versus you have the approach that I just want to get to point B. I do not care how it is. I want it to be easy. So you would just grab a car and try it. It's that simple. So there are various ways of how we run our code today in the cloud. It could either be that you have code or you have container images and you just say like, you want this to be executed when needed at any scale. So you do not want to take care on making it highly available from your end because you're losing money and it's making a lot of cost on top. And you also want to make sure that if there is too much workload coming in, you need to be scaled quickly that you can surface every of the requests that's coming to you. So that's exactly the use case of when you would think that serverless makes sense. So what is serverless? Serverless says it runs your code only on demand on a per request basis. That means You do not need to take care on making it highly available. You do not need to take care about how much your cost is going to look like, because it's going to run only on demand. You do not need to have any sort of management of your infrastructure, or you do not need to care about all the compliance and operations of your infrastructure. The scaling is totally transparent. Like, however many requests are being made to your application, accordingly, the scale out of the functions is going to be done. It's not going to be scaled more or less. Which brings to the point that you're paying only for the resources that you're using. So whatever CPU, whatever memory you're acquiring is the only thing that you're going to pay for. The major focus that serverless wants to bring in is that we need to develop more value-adding code, and we need to drive the innovations rather than getting busy with the management and operations of infrastructure. So all it says is no servers, just code. So I've talked about something called a serverless, and then something called as functions as a service. So what's the actual difference between the two? When we're talking about all of this during the whole session, it is not to push you in one direction saying that functions as a service or serverless in general is the correct choice for all of your work that you're doing. No, that's not true. There are many cases wherein you need to decide, depending on what kind of application and what kind of use case you have, probably infrastructure as a service makes more sense. I'm just trying to introduce to you what serverless means, how you can leverage the facilities that serverless is providing to you, and how is it better than the other paradigms we're going to talk about. And as the name serverless, which might be very interesting, it means no servers. So obviously for you as a user who's trying to deploy their application, get their code to be running on cloud, it's serverless. You do not need to take care of servers, but there are servers running somewhere. You just don't need to babysit them. So that's the task that we as the service providers of serverless system here are going to take care about. So what is functions as a service? So functions as a service is a type of cloud computing service that we've just spoken about. You execute code in response to certain events and without the complex infrastructure. So for example, you are getting certain event and then you decide that your piece of application needs to run. The event could be when users are actually trying to access your code, or it could be a trigger which is external. For example, you're getting certain sort of sensor data. So there are a lot of IoT applications where you want to do a particular set of tasks when your sensor is reporting a particular amount of data. And then in that scenario, serverless or functions as a service makes total sense. So as it says, execute your code in response to certain events without the complex infrastructure which you need to put in, and simply launch a microservice application. And hosting a software application on the internet typically requires provisioning and managing of such things. What FaaS does is that you do not need to take care about that. You focus on how you need to write your functions, how you need to make them efficient, and how should your event response look like. So functions as a service is actually a subset of serverless, because serverless could be in many paradigms. It could be related to compute, to database, to storage, to messaging, to API gateway, where the whole system behind, the whole server setup behind is totally abstracted from the user, which is majorly developers in this case. On the other hand, it's also probably the most central technology in serverless architecture. So even though I said like it's a subset, it's totally focused on event-driven computing paradigm. And that's exactly what we're going to see now. So in traditional models, when you're having, let's say, a typical application that you're trying to run, be it could be a container, it could be a virtual machine, or it could be a Cloud Foundry application. What are the things that you do? You need to take care about scaling. How fast can you scale? How much memory, CPU response time, how much do you need? And many times it's not something that you're already pre-aware of what things do you need and what things you need to keep in mind. For example, you have created a shopping application, which is probably not so popular during the non-festive times, but during the Christmas time, you expect a lot of workload to be coming in. And you need to take care about scaling of that particular application on your own if you're following the traditional model. So you need to make sure that you have enough memory, CPU for your application to be running when you have too much workload coming in. You need to take care about resiliency, the same thing, that you need to make sure that you're highly available. So if one of your applications for any reason goes down, you should still be able to serve your requests that are coming in, and that's why at least 2 processes are needed for being highly available. You need to make sure that they're healthy and running all the time, despite the case that you're using them or not. And you would generally try to deploy them in multiple regions around the world so that they're accessible from different locations. So the major problem in here is, depending on high availability, you're actually paying all the time, even if your applications are idle and they're not getting any requests, because you need to make sure that you're highly available. There is a major thing that's missing, which is something like, if you want to respond to a particular request only, then you do not have some sort of event-driven model in the traditional way. You generally do polling. So you're continuously polling to get to see if there are any events coming in. So any of the broker or queue applications that you have, you're generally always polling to check for if there is something new coming in the pub/sub model. What serverless does it, on the other hand, is that it scales per process per request. So for example, if you have 2 requests, there would be 2 separate functions running for you. If you have 1 request, it would be only 1 function running for you. And if you have 10,000, then the 10,000 functions would be running for you. And what exactly functions mean in the sense is, we're running containers for you. So you provide the code, and we would wrap your code into a container, and we're going to run those containers. So if your workload is not that high, we're going to kill the containers from before. And if there are certain cases when you have multiple requests coming in, then we'll start scaling them out inherently. So you don't need to have any cost for resiliency, because we make sure that it's highly available. We are always going to scale out, and we're always available in multiple regions. So you do not need to take care on taking any risks regarding resiliency here. You only pay for the process that's actually running. So you do not pay for the containers which are not being used currently. And this allows you to also have low operation costs. It introduces event-driven programming. So for example, in this case, if you see 1, there is a trigger. 2nd is the engine, which is sitting in the center, which is IBM Cloud Functions. It will receive that trigger. And there are some rules that we have to define in order to understand if certain trigger happens, which action is supposed to run. That's point number 3. And then the action are run. The deployment of these actions happen within milliseconds. They run it, and then they free up the resources once the job is done. And that's the most powerful part of any of the serverless model, that it scales really fast. The actions are responded within milliseconds, and they're freeing up the resources as soon as possible once the request has been processed. What kind of actions can you have? There are multiple options for you. We support most of the runtimes. Most of the competitors support all the runtimes that are available. And if there is something missing, then we also allow Docker images to be sent. So IBM Cloud Functions can also wrap around your Docker image and run that as a container. There are also different application models. So we've all come from the monolithic architecture to microservices and then to functions. So monolithic is all that you're deploying everything as a single unit. And when you're trying to introduce even a single line of code change within your applications, you have to deploy the whole application. So you cannot just do the change that you did. Then came microservices, which were more like you define the functional component of your application, and it introduced a lot of decoupling, which made life much, much easier in many cases where monolithic was not the correct option. So now you have your UI as a separate microservice talking to your backend as a separate microservice. You have your databases and middleware. So you have kind of separated them. And if you have any change that is supposed to be done in only one of the parts, if you change something in the UI only, you do not need to take care of any of the other parts. FaaS or functions further is much smaller than that. So it decouples it much further that you allow your function, one particular unit is going to do exactly one task. It is totally up to you how you want to define your functions, but functions are supposed to be really, really small logical units, much, much smaller than what your microservices are doing. So for example, if in UI you have a shopping cart, you have payment, you have the display where you're showing the catalog, these all can be divided much further into functions and you have much more dependence. And as functions offer, function as a service offers, you don't need to take care of the infrastructure. So I think we have established this already, that serverless promises to developers that they do not need to take care of any servers. They do not have to worry about the service. So for their perspective, they don't have a server. You don't even need to start up a server or write a code to maintain a server. All you have to do is just provide a business logic. They are event-driven. Many of the workloads are certainly so that you want an event-driven kind of model, and serverless fits there. It is scalable. It is highly scalable. You do not need to take care of that on your own. It is pay per use, so you're saving a lot of operational cost, plus the cost of maintaining multiple instances of your applications. You can actually integrate your function with lots and lots of various cloud services. So be it any of the cloud vendor who has a service currently running which offers serverless model to you, they always allow you to integrate with tons of other microservices and other cloud services. For example, you can have IoT services, visual recognition services, machine learning models. And some of this is actually what we're going to see in the demo that I'm going to do today. So you can also attach to databases, so on and so forth. What in the end it is actually resulting is that it's decreasing your time to market because you're not focusing on the other things that for sure are important for your application, but do not fall into the category when you're trying to actually deliver your product. Serverless abstracts away the most manual parts of building an application, leaving developers free to actually spend their days coding only. So what's IBM Cloud Function doing? So the FaaS platform to execute code in a serverless fashion on IBM Cloud is a managed service called IBM Cloud Functions, which I'm going to share today. This is actually based on the open source project from Apache, which is called Openwhisk. And Openwhisk can be downloaded and installed on any of your machines. So you could also do it on your laptop. You can do it on any hardware, anything that you manage. So it's readily available. You can do it. What we do for IBM Cloud Function is that we have deployed it on Kubernetes. So I, as a developer for IBM Cloud Functions, we make sure that the infrastructure requirements for our users are fulfilled, and we have put them all on the Kubernetes clusters, so the underlying infrastructure is Kubernetes. It does not matter to the user. It's just an information just for you to know of how we operate. But for you as a user, it is totally transparent to you. You would not even know on what kind of infrastructure or what kind of orchestrated tool we are using underneath for handling the requests that are coming to us. Any of the language or binary is supported. So we have the major ones, Node.js, Go, Python, Java, and there are multiple versions that are generally supported, and they're also performance optimized. So we have our own set of runtime libraries that we support from within, and we've tried to keep it to a minimal, but still trying to solve the major use cases that the users have for us. So if you want to introduce something on top, we provide you the environment, but if you want to have certain libraries on top, there are ways to do that too. But we try to provide the minimal set of requirements that we generally see, which are popular relating to a particular technology, and all those libraries are inherently supported. If you have any other language which we don't support yet, like I said in the starting, you can provide us your container image, and we can run that too. There are various invocation models that we support. One is blocking. So for example, you want for your request the answer to be given immediately, a synchronous request. Then there are blocking models. Non-blocking are that you send a request, fire and forget. You would get an activation ID from us, and you could use that to retrieve your results later. That's a non-blocking mode. And then you have periodic functions when you have certain sort of cron jobs that you want to run on periodic ways. These are also inherently supported. There are much higher level program constructs. For example, you can chain multiple actions. So each function could be a combination of triggers and actions. And you can try to pass one information from one of the action to the other, and so on and so forth. And this is called chaining or sequencing that we'll see later. And there is also parameter binding. You can always provide as many parameters in any form that you want to be provided to your particular function as an input. And you can do these as well with Event Cloud function. Event provider. So there are a lot of possible options in the consumer ecosystem for event emitting. The same as like we have a lot of interfaces for the event emitters as well. So you can try and mix and try to feel what's the perfect use case for you. You can try and play around with a lot of services that are available around. Some of the most popular ones are, like I said, periodicity. So the cron jobs, we have Cloud and Database, Message Hub, or Kafka Queue. In general, API Gateway, push notifications, GitHub, Slack, Watson Conversation, App Connect, so on and so forth. About the pricing, just to give you an idea, generally for any of the serverless model that you have, you pay only for the exact time your action is running. So how is that calculation done in general? When your action is not invoked, when your function is not running, it's not in the memory, and you're not paying anything. So only when the request is coming, your request is getting processed, we send a response, then is the time when actually the pricing is going to take place. And the pricing model is simple. We do it time an action was running, so how long did your action run for, and how much memory allocation did that action use. So that's the calculation, what we do in order to price for any of the function invocations that you're doing. And as you can see, the numbers are pretty huge in terms of how much you get in free tier already. And the price is pretty small. So there was a research done, and we tried to check what's the pricing model looking like and how we are pricing it. And it seemed to be one of the cheapest serverless platform. But as you see the numbers, it's pretty easily available. If you want to try this, you're way well in the free tier. You can definitely give it a try. So now it's time for demos. I'm going to take you guys to what functions is on a very basic level. Miriam, I need another confirmation from you. Do you see Cloud Functions?
Yes, I do.
Okay, perfect. So this is a URL, cloud.ibm.com functions. You can go in here. I'm just going to talk very brief about what are the basic things that you need to know about before you get started. And the first thing is on the left, you could see there is documentation around, there are tutorials around to see and learn how you can actually write your very first function if you have not used it before. And what are the different sample use cases that mostly are very popular around in here. And the information about what type of runtimes we support, the event providers, so on and so forth. So you guys can try once you have your IBM Cloud account ready. Here we have the other things, which are like actions, the functions which you actually want to run, the triggers, which would actually trigger your actions, certain APIs that you have exposed with your functions. I'm going to talk about that later. You can also see all the logging of how your functions are performing and the results. And inherently, there is a support for logDNA, for system logging and user logs to check how your functions are performing and debugging. Similar is for monitoring, which allows you to get the matrix onto Sysdig instance. And there you can also have all the kind of matrix that you need for your function. So the main thing that is important here is a namespace. So for those who are familiar with Kubernetes, probably they know what a Kubernetes namespace is, and it's like the parent entity which contains all the other entities within itself. It's a whole. The same thing applies here. We have something called as a namespace, wherein you can bind all your actions, all your triggers, all that belongs to one particular set, and that would be called namespace. So you can have multiple namespaces as you wish, but if you have one trigger that's invoking a particular action, they all need to belong to the same namespace. So as you can see, I prepared something called as meetup demo for us. There are multiple regions that we support, and Frankfurt is one of them. So this is where I'm going to be. So very brief, very easy Hello World application that I'm gonna show you today. So you can go in here, you can decide that you want to do a particular action. Hello World is the name, and here you can pick the runtime that you want to have. So I'm going ahead with Node.js, and you create your action. The first thing that you already see in here is that it's a hello world, so it's doing nothing. It's simply returning a hello world to you. Here is the invoke button, and here you can invoke it. And as you can see, it took 30 milliseconds to get the result out. And here you can see that was hello world. There are some more concepts that I'm going to talk about later of how this time for the action to run and response could vary, and that I'll talk in detail. Here are where you can bind the parameters, or if you want to just test your function, you can invoke it with any parameter in here. You can also make your application a web action, meaning you want to expose it over the internet, and you want any of the HTTP requests or HTTP events to handle. So all you need to do is you can enable that and save it. So basically, you have this URL, and if you click onto that URL, okay, let me copy that into it. You can see the hello world. So there are different extensions that are supported inherently. Whether you want to get a JSON output, you can do .json, there's .html, so on and so forth. But this is something that's now exposed to the internet, so anybody can use this, and it is as easy as this. So this was a very basic hello world kind of application that I just showed to you guys. And then moving back to the presentation. Let's talk about some of the real use cases that we get, like the actual use cases. And before that, I just want to talk about how your actions are actually running. So whenever you send a request to your function, or in my case, like I did an HTTP request to the URL that I had for Hello World, what exactly happens is kind of equivalent to what you do in a Docker run. So whenever we get a code from you that you would want to run as an action, we pack it into a container. And all we do is when the request comes as Docker run. So it would start creating the container for you. So the first step is, and this is something as called as cold container, and I'll tell you why it makes more sense. So whenever you're running your function for the very first time, or you're running it after a really long time that we have kind of removed your container, and you're trying to recall your action, then we're going to build your container again from the scratch. And that's the condition what we call as cold container. Now, there is something as pre-warned container. So once we have started your container, there comes an init phase where we understand what the runtime requirement you have. For example, mine was a Node.js 10 action. So we would inject the container with the runtime Node.js 10. For these as well, we have some containers which are already containing these runtimes. So we have some pre-prepared, or you could say pre-regged containers, which are containing the runtimes like Node.js and one for Python, so on and so forth. And when your request comes to us, and we already know this is a Node.js action, we are going to pick the existing container. That's the initialization phase. And that's why it is called pre-warmed container, because the container already contained the runtime information. Then is the phase run, that your actual code gets injected. So one was that there is a container from scratch, which has no information, what kind of runtime you need. The second phase is when we actually get to know about the runtime and we've injected the runtime, and there was a container from before which contained your runtime, the desired runtime. And the third phase is run. So when there is a condition that everything is known to us and the code is injected, your container is warm and would respond to you much faster than what it was doing for cold container. So that's the performance. If you're running your action with a very long span of time in the middle, or you're running it for the very first time, we offer to you cold container because we do not have information about what the function is. In cases when you have been running it rapidly, but not that rapid enough, we already have the information about what type of runtime you need. So you get a pre-warmed container. But if you're running your application rapidly, if you're getting request pretty rapid, then it's always a warm container, that your container which was containing your function is still running and it actually never gets scraped off. In that particular case, the response that you get from your container or your function is very, very fast. And that's how performance matters here, of what type of container are you trying to use here. So if you have an action which is running much faster, then you're probably going to get a warm container and it would process your request much faster. If you have certain cron job, let's say, which runs only once a month or once a week or so, then you're probably going to land into cold container condition. How you can manage it is simply depending on what kind of workload you have. If you have certain requirement where your application needs rapid running and it keeps running all the time, your response times are going to be much, much smaller. So the serverless application platform, there's always a new addition. There are always new services coming in, and there are much more build application topologies which are totally serverless. Like I mentioned initially about, there are ways where you can have storage serverless, you can have databases serverless, you can have much more other things. So there are a lot of different support. Cloud Functions, for example, is a compute model. Cloud and object storage is something for storage, so on and so forth. Volatile or event-driven workload that we've been talking about, they can be split into actually really short-running pieces. And when you have sporadic requests coming in, as well as heavy load scenarios, it's very easy that the functions can handle it if you orchestrate your functions in that way. So the common use cases are serverless is used for doing API backends or for microservices, for mobile backends, for parallel data computing processing, data at rest processing or cognitive ability data, event streaming, IoT, conversational application, chatbots, and so on. Massively parallel compute and map operations. So there are a lot of work that you could do around with multicolor symbolizations and so on and so forth. And you can have scheduled task or cron jobs running. So these are some of the most common use cases where serverless is heavily used. For example, for mobile backend, we have a customer called the Weather Gods. And they are using IBM Cloud Functions for serving the requests that they're getting from the user. And how that happens is pretty straightforward. So they have a cron job, which runs every 3 minutes. It kind of gets the information from the cloudant about which user has subscribed to the information for which location. For example, I'm living in Stuttgart. I'm interested into getting the weather about Stuttgart, and I have this app where I would like to see what it is. Whenever there is an update done to Cloudant, whenever a user has updated any location information, there is this weather checker engine, which actually talks to the Weather Channel API in order to get the information. And then it updates another Cloudant entry, which is a trigger for the rest to do. So for example, I am in Stuttgart, and I could even further mention that I am interested to know if it's going to rain tomorrow. So when I do that, the information about rain is something that's going to the Cloudant database. And whenever there is an update on this, they have furthermore divided the different types of weather, like rain, snow, wind, for example. And when a user for a particular location is interested in a particular form of information, only that function is going to run. So for example, I'm only interested to know if it is going to rain or if it is going to snow in Stuttgart. The other functions will not run. So it totally depends on the user preferences that you have, and that particular function will then run. Then they have a notification trigger, which sends more information into Cloudant, that what is the information that you need in order to notify the user. And then the notification is being sent via another push notification service that we have in IBM Cloud, so that you get the push notification stating that the weather in Stuttgart from the rain perspective is going to be so and so. So the idea here basically is this, that you can finally define your functions like they have done for rain, snow, wind separately. And you can define what the notification model is going to look like for them. So if a person is not interested to get to know about storm, the function is not going to run. That way you're saving costs. And if there are multiple requests coming in relating to rain, it can scale independently from the other functions. So it is pretty efficient of how you can break your functions and get the maximum out of it. For data processing, it's this application which deals a lot with text, audio, images, video data. You can do a lot of other things on this. For example, you can push the data or put your pictures or video onto a particular database, which would act as a trigger to invoke a function where you can do any type of image processing and then provide the result back. One such other example is there is a website called SiteSpirit, which basically tries to get the information about the pictures that the users are uploading. They try to transform the pictures, and they, in the end, try to get the correct information about the pictures, also probably do tagging, and then store it back to the user's database so that they get to know about this. So as it says, it's pretty straightforward that if you want to scale only one part of your application, because that's the only one which is getting most of the requests. For example, if you're getting most of the requests for image cropping only, you do not need to take care about move and upload stuff. You can independently scale out just the image crop. And when the request goes low, you can squeeze back to the basic number that you had. So the second demo that I wanted to do, which is actually a demo that I wanted to show you guys, was mop or dog. So I have certain pictures, and I would like to feed them into my function, and would just like to check the tags on these particular images, try to check whether it's a dog or a mop. So I'm going to upload a picture onto one of my Cloudant instance that I have already on IBM Cloud Function. Then I have a trigger which triggers anytime there is an update done to Cloudant. My one of the function is going to read those changes. It is looking for a particular value, a particular property key value within the Cloudant database. And when it gets that value, it's going to call another function, pass that value over to another action. And this action is talking to a third-party app, which is the visual recognition service, Watson, also from IBM Cloud, trying to get the information about that particular image, and then sending us the tags which are related to it, which would help us guess whether the picture that I submitted right now is a mop or a dog. So that's how I have defined the functions for my particular application. And as you can see, this is what is meant by chaining. I'm trying to pass certain information from my trigger to my function and then to get classifier's function so that it uses that particular information to run the visual recognition service. And now I'm going to show you how I did that. Oh, not the other one. All right, so like I told you, we have certain actions created in here. Before that, I just wanted to show you that I have a Cloud instance to which I call it Cloud Dog World. And when you go inside that particular instance, you can launch your Cloud database. Here it is. I have a database called, I need to do that again. So there's a database called Dog World, where I'm actually creating documents for me, where I'm keeping all the dog information. So I already have one, wherein you can see that I'm providing a value which is called image URL. And this is basically pointing to some of the images that I have on my GitHub. So I have a couple of images. We're going to give this a try. We're going to feed another. We're going to create another document into the Cloud database. And then we're going to see how this actually runs my function automatically. But before we do that, this was just the external setup that I had to do for my database. Going back to the actual function. So what I did in here is, as you can see the details in here, it's a sequence. So I have one, which is a sequence, which is actually going to get the information from the trigger and pass it to the next function. And this is my actual code. So let's get in. So this is a Python application. It is pretty simple. I can use the Watson recognition service because we provide that inherently with our with IBM Cloud Functions. So all you need to simply do is import that, get that. What I do here is I need to authenticate for this particular visual recognition service using an API key, which I have passed here as a parameter. You could also do it here when you want to invoke it directly from here. And then I'm looking for something called as image URL. This is something that I'm passing down from my Cloud database. I would then simply run visual recognition classifier API on it and try to get the tags out and print that result. So it's a very small function. It's doing exactly getting the image, applying the classify API on top, and just showing the result out. So if I do this right now, it would definitely throw me an error that I do not have any image URL provided. So just for an idea, let's go back in here. I can copy this field as is. I can go back to my function and say that I want to invoke it with parameters. So now I have this, I apply this, and then I can invoke it. If I invoke it directly from here, it's going to give me the information about what that particular image tag was that I provided in here. So as you can say, it says it's definitely not a dog, it's a mop. As you can see with the tags that it says, it's a cloth, it's an ash gray color, it's a fabric, so on and so forth. So that's the way how you can test whether your application is running or not. Now, the best part would be that if I get to show you how the sequencing is working. So let's get back to sequence. So you could also create sequence as you create an action, like I showed you for Hello World. What I did here is that I am trying to read my Cloud database. So you need to associate your Cloud trigger with this particular read operation. So as you can see, this is something that is provided by functions. You do not need to create this. All this is doing is that you need to correctly attach your Cloud instance with it. And that's pretty simple as well, because just to show, if you create your sequence for the very first time, you get in here, you have options in here of how you can attach. So let's say in my case, I said I'm interested in the Cloud one. I can create a new binding because that's the old one. And here you get all the instances. So here you see Cloud Dog World is the one that I was interested in. It's reading the dog images database. If you have multiple databases, you could also select that from here. And that's how you can create a sequence. So I already did that. So going back to actions and back to my sequence. So basically, it's trying to read the values from Cloudin, get the image URL value, and pass it on to my get tags, which we just saw. And then get tags is talking to visual recognition service, so as to map to what I showed you as the basic flow of this application. Now, to see it in working, I'm going to go to the activations dashboard. And here you get all the information of what exactly was working. So for example, I ran the get tags as well, where I said it's a mob for sure. So you can see the activation log in here. The one that we ran, the Hello World program, and so on and so forth. You can get all of these information in here. So we're going to be observing this part, because now when I upload any new document to my Cloudin dashboard, it will trigger the sequence, and we should get the response about the get tags in here. So I'm going to pick an image which is a dog, and it's mob or dog one. I'm going to copy that. I'm going to go to my Cloudin database, create a new document, add image URL variable to it. I want a raw image for being processed. I'm creating a document. Now that I have created a document, if I go back here and try and refresh, you would see that the Cloudin dog was actually running. So it got the information. Just curious, did I miss that? Let me check again. Interesting. Let's check the dashboard again. Why is it complaining that it's missing the information? Okay, I was looking at the wrong value probably. So here, we had a Cloudin read where it was actually reading the information from my Cloudin account. And here you see that it found out that it's a dog and not a mob, and what kind of possible dog this could be. So it is that simple that you just have to do one sort of invocation. You just need to trigger the particular function to run, and you see here the result of it. You can see how long it took. So if you want to have now a much faster response time of what it actually took to show you the values, like I said, if you have a warm container, that's the best case. If I'm doing this request, or if I'm keeping and uploading my Cloudin database with new information all the time, then I would have much, much, much faster response time compared to what you get when you're doing it for the very first time or after a really long break, because now I'm getting a cold container start. So it was just to show how you can bind different cloud services and try to get the max out of it, like how easily you can get the information out. Going back here, that's all from me. Thank you so much for listening. And now I think we would be open for questions here.
Great, thank you so much. It was a really informative session and such a great talk. We have got 2 questions in the Ask a Question function, so I can take you through, I can read them out.
Sure.
Can I call this function directly through HTTPS like in Firebase functions?
So there is a way you could have API gateway in front, which would allow you to do HTTPS requests. You can find more documentation. We support that too, yes.
Awesome. The second question is, can this cloud function grab data from the database when it gets triggered? If yes, can it cache these data?
So generally, functions are supposed to be stateless. So you would not want to actually cache any sort of data. For any sort of operation that's happening on your database, like for example, I was doing a read, there are tons of other options that you can have on delete document or trigger update document or so on and so forth. But caching is not something that inherently is provided because it's supposed to be stateless. But if you want to do a caching on top, then you need to come up with a solution of your own.
Great, thanks. We've got a question in the chat. Can I add libraries, for example, to the default Python functions?
Right. So there are also ways of how you can add library. You can also have virtual enums. You will all find it in the documentation, and yes, it's possible.
Great. That's all the questions we have so far. If anybody else has a question, feel free to type it in the chat or in the ask a question function. We'll give you a couple of seconds to type that in. But otherwise, I think those were all the questions we had from the audience today.
Great. And I would just like to add something in the end. So what I just talked about has also certain restrictions or limitations. For example, how long can your function be? Because function is supposed to be really, really small entity. So the maximum time that your application can run for is 10 minutes. And default is 1 minute. So if you want to extend it from 1 minute to 10, you need to send us a request and we can do it. But there are certain limitations like these, like how much long running they can be and what are the other sorts we provide and many other things. So we have another product that's going to be talked about. I think, Miriam, correct me if I'm wrong, on the 5th. That is called Code Engine, which is kind of our serverless 2.0. So this is serverless 1.0, which we were running since last 4 years. And now we have introduced something new, which supports scaling to 0 functionality, which supports running batch jobs efficiently on serverless platforms. And you're going to hear more about this. So if you're really like this session, I would highly recommend you to attend the second session because this would open you much more. It would provide you much more ideas of what all you can do with both of these serverless functionalities that are available. Yeah.
Yeah, great shout. So it's the 5th of November. I've posted the link to the meetup in the chat so you can access it quickly. We have another question. You called Watson for a prediction. Can you upload weights of your own network so that a single function will predict, or do you always rely on a separate item?
You can, but again, the point being your function should be as less weighted as it could be. So I prefer to use a third-party application for this. But if you want to do it within your function, you can for sure. But like I said, you have these limitations of how long your application can be running for, so on and so forth. So it's definitely feasible if you want to do it by yourself rather than using something like Watson. But yeah, that's just something that I use, which was really quickly available to me. And I just didn't want to make my function really bulky.
Great. Thanks for your questions, everyone who asked one. And we're getting lots of thank you and praise for you. Thank you so much, Sugandha, for coming and talking today, for sharing all this wonderful serverless stuff. And I loved the dog versus mop. That's amazing. I've never seen that before. That's so awesome.
Thank you. I'm happy that you guys enjoyed. And if you have any questions, find me on Twitter. You can reach out to me. And I work for both Cloud Function and Code Engine. So even if you have questions for the next session, feel free to ask. I'll be happy to answer.
Thank you so much. The chat is just full of praise and thank you.
Thank you. You guys are generous.
So I'll close today's session, and if you want to watch it again, the replay will be up with the same link. So feel free to watch it again. Have a great evening, everybody, or have a great day.
Thank you, Miriam. Thank you, everyone. Bye.
Thanks. Bye.